Okay. So now we are going to study one of the example on water turbines. So that one is a Pelton wheel. Pelton wheel. Okay. So we are going to study the Pelton wheel. So now we have to listen carefully how to write it and all. So while explaining only I am going to write it. Okay, explain Martha, I am going to write it. So it consists of shaft. What is this? Okay. And also the rotor is mounted on a what is this? Rotor. Center per okay. So this is a shaft and this is a rotor. So on this rotor we are going to have a into what is this? It looks like a sun. Okay. So this is a rotor and it will be having a double hemispherical shaped blades. Okay. So this is one hemisphere and this is another hemisphere. It will be joined. Double hemispherical shaped blades. Okay. So that's why I have to represent it properly now. So these are the blades. What kind of blades? Double hemispherical type of. Is it clear? So now I need to enter. I need to supply the water, right? What is this? Water. Right. Super. So this is a tangent. Why I am writing like this? Because this is a tangential flow impulse water turbine. See, this is a rotor. So the water must be tangent to the rotor. So that's why while writing you should be careful. First you have to write the rotor, then blades. After that you have to write the water. Then you have to write the nozzle. Don't start with the nozzle. Okay? So now I am going to write the nozzle. What is this? So this is a nozzle. See, I can control the velocity of nozzle. How I can control? So with the help of one assembly, needle assembly is there. By varying this, I can control the flow of water. Is it clear? What is this? This is the nozzle. Okay, this is the assembly. So this assembly is placed inside the where? Super circle. It is placed inside the casing. That's it. Okay, so this is the casing. What is this? Casing. C for casing. N for nozzle. Next, this is for double hemispherical blades. Double hemispherical blades. And what is this? R stands for rotor. That's it. No? Shaft. S stands for shaft. So what is this? Pelton. How to write it? So this is the penstock. This is a nozzle. So this a long tube will be there. So that is a penstock. It is called as what? Penstock. P-N stock. S-T-O-C. P-S. Penstock. Is it clear? So this is the construction part, or this is how you have to write the sketch. The main important thing that you have to focus is the flow of water. The flow of water must be tangent to the rotor, then only you are going to get the marks. Okay, please be very clear about this. What is this? This is a tangential flow impulse water turbine. So that is the first important thing that what we have to write. What kind of turbine is this? It is a tangential flow. What type of impulse and requires high head. TF high HH. So we already know the classification, right? So what are there are three classifications are there. So we have to write the first statement based on the classification. What kind of turbine is this? This is the tangential flow impulse water turbine requires high head. Requires high head and less quantity of water. And requires less quantity of water. So this is a very important sentence that you have to underline. Next you have to tell about the construction part. So Pelton wheel consists of a rotor with double hemispherical shaped blades mounted on it. Okay, and this rotor is mounted on a shaft as shown in the sketch. And also it has a nozzle, which is connected to the bench. That's it. Working is very simple. Next one is working. The construction is over. Next one is working. So what happens? Water from the reservoir flows to the nozzle through penstock. So penstock is nothing but a long pipe. It is a huge pipe. It is connected to the reservoir. So water will be stored in the reservoir. So the water has to flow from the reservoir to the nozzle. Through where? Penstock. Okay. So while flowing from reservoir to the nozzle, so there will be some conversion of potential energy to the kinetic energy. So stored water means what? It is an example of potential energy. Okay, it has to be converted to kinetic energy. So that will be done in the bench. This kinetic energy of water is flowed through the nozzle. What happens? The velocity of the water is going to increase. So this high jet of water, you have to tell perfectly, this is a high jet of water is going to strike the blades. What kind of blades? Double hemispherical shaped blades. So this results in what? Impulsive force. Due to this impulsive force, what happens? The rotor is going to rotate. And the shaft which is connected to the rotor is going to rotate. So this is how we are going to convert the kinetic energy of the water to the mechanical energy. I hope you understand. Okay. Once again I am going to explain. Please listen carefully. So that is how you have to write in the examination. I hope you understood how to write it. See, I started with the writing the shaft, then rotor, then I written the blades. After writing that, I have drawn a water, right? Jet of water. This is the jet of water. Is it clear? After that, I written the nozzle assembly and also the case. So this is the way you have to practice. It is very easy. Next, you have the explanation part. The main first important sentence that what you have to write. What kind of turbine is this? So this is a tangential flow impulse water turbine. Requires high head and less quantity of water. So that statement for 2 marks. Done. Next one is construction part. It consists of what? Rotor with double hemispherical shaped blades mounted on a shaft, and also it consists of a penstock with nozzle. The assembly is mounted inside the casing as shown in the sketch. Next one is working. Okay. The water from the reservoir flows to the nozzle through bench, where potential energy of the water will be converted into kinetic energy. So this high jet of water from the nozzle is made to pass the blades. High jet of water is going to make or pass the blades. So due to the impulsive force, the rotor is going to rotate. So this is how we are going to convert the kinetic energy of the water to the mechanical energy. That's it.